So function notation is a way of communicating to your what you want to have done. So they will replace y, like if we have an equation y equals 2x plus 1, they replace y and they call it, well, this is a function. So we're going to say this function of x equals 2x plus 1. And a lot of times students are like, well, why can't we just stick with y? That was doing fine. Well, if we have two equations like y equals 2x plus 1 and then y equals 3x, if we're saying this one equals y and this equation equals y, well, if they both equal y, then they must equal one another. So we have to have a way, to say that they're not equal to one another. They're different functions. So we start with f because of the word function. And then if we had a second equation, we would call this one g of x, because guess what? G comes after f in the alphabet. And then you'll see h of x used, and usually that's as far as they go, but it can be anything. What's nice about function notation is it's telling you which equation to use and what to put in for x. So if you see a function notation of, like, let's say f of 2, they're saying use the f function, so this is telling you which function to use, and put 2 in for x. So I look up at my two functions here. Oh, okay. Everywhere there's an x, I'm going to replace it with 2. Now I'm going to simplify. And I'm not going to do anything with the f of 2 because remember, those are our instructions. Or they're just saying what we did. At this point, they're telling the reader what you did. 2 times 2 is 4 plus the 1. So f of 2 equals 5. This is a great way. We don't have to write a whole bunch of words out. And we know when 2 is put into the f function, the result is 5 from function notation. So let's practice a little bit more. What if we go to f, and I'm going to change it up, have a new equation, f of x equals negative 3x squared. And let's try f of 2 in this case. So by using this function, negative 3, I'm replacing the 2 for the x. Remember, respect your PEMDAS rules, so 2 squared is 4 times negative 3 makes negative 12. But what if they told us f of x equals negative 48? This is a way of saying that the output now is negative 48. Find what x is a lot of times, is what they'll say. So we go, okay, well, our f of x equation is negative 3x squared. So I know that equals negative 48. Divide by negative 3, divide by negative 3. X squared equals 16. We square root both sides. Remember, you're the one putting the square root in, so you must add a plus or minus. You don't know if it was a positive or negative 4, so x equals plus or minus 4. There's another equation. We'll do g of x equals negative x squared plus 4x. I bring this one up because I noticed that it causes a lot of people trouble, this negative in front of the x squared. Order of operations says that you're going to square the x first, then multiply it by the negative. So if I have g of negative 3, negative, notice that I'm leaving the negative outside there. And everywhere I'm putting an x, I'm replacing it with negative 3. Be very careful with your negatives. So negative 3 times negative 3 makes a positive 9. And 4 times negative 3 is negative 12. So we have negative 9 minus 12, so that equals negative 21. So with this, notice the negative is there. Don't just put this in your calculator, because calculators don't always respect order of operations, or they respect it differently than you think. So make sure you're checking. If you're putting in the calculator, oh, when I square the negative, is it going to become a positive? And then I times it by that negative out there.